Hi, you're right. This is our second lesson looking at simplifying algebraic expressions, and we're just going to be looking at collecting like terms where there may be more than one pronumeral, there may be powers greater than 1 in the algebraic expression. Before we dive into that, let's just go back to what we've already learned. What is important when we add and subtract algebraic expressions? Firstly, let's go one step further. What is an algebraic expression? Okay, well, an algebraic expression is basically something containing pronumerals with operation symbols. So this, for example, is an algebraic expression, as is this. That's an algebraic expression, as is this. Also, this could be an algebraic expression. Okay. So the important thing when we're trying to add or subtract these types of algebraic expressions is that they must have like terms. Okay, so to add or subtract algebraic expressions, like terms must be present. What do we mean by like terms? Well, like terms are basically letters with the same pronumeral part. So if we go up here, for example, these are like terms, and we could simplify that to 9x. However, these are not like terms, so we cannot make this 7y or 7xy. Impossible. How do we add and subtract? Well, basically, if we have an algebraic expression, so say I have 4ax plus 6b plus 7ax minus 4b. Okay, now the instruction here would be to simplify. So these are the sorts of questions you're going to get. Now if I want to add and subtract this or simplify this, what I need to do is find the like terms. Now ax is here and here, so they're like terms, and there's a b here and a b here. So those are like terms. The other thing that's important is that you take the operation symbol in front of the term. For example, for this one I've got 4ax and there's a 7ax here, but before the 7 there's a plus. So all of that goes together. So if I'm going to work this out, I've got 4ax plus 7ax, which is 11ax. And then I've got 6b minus 4b, so I take that, everything with that together. And the like terms no longer exist, so that's my final answer. Let's have a look at some more examples together. Okay, the instruction is to simplify the following algebraic expressions. So anytime it says simplify, it means you want your answer in the smallest way possible, but only by collecting like terms. And they're telling you these are all expressions. Some of these get quite tricky, so let's have a look at a few of them together. The first one, for example, says 5 lots of x minus 9 lots of x. Now they are like terms, which means I can do 5 minus 9, which is minus 4, and I put the pronumeral in. Let's try another one. Let's try, for example, question n. 5x squared y minus 15x squared y. Now are these like terms? Yes, they are, because they have both they have both an x squared y term. So I'm going to do 5 take away 15, which is negative 10x squared y. Okay, so sometimes here now we're even looking at where operation symbols are different. Let's even try question m. This is a bit of a tricky one. In question m it says minus 4p plus 6p minus p. So I've got minus 4p. Now plus 6p minus p is 5p. Because anytime there's nothing before the letter, there's really a 1 there. So that's 6p minus 1p, which is 5p. Now that is equal to minus 4 plus 5, which is 1p, but I'm not going to write the 1, because in algebra we simplify everything. Let's have a look at question k, because this is an important one for symbols. This says minus 8n minus 3n, and they want us to simplify this. So let's have a look. The minus, I'm going to leave the minus 8n out the front to begin with. I've then got minus minus 3n. Now two negative signs directly next to each other become a plus, so it's going to be plus 3n. Do I have like terms? Yes, I do. So what I'm going to do now is do minus 8 plus 3, which is minus 5n. Let's go down and have a look at some further examples. This time we need to be careful with the operation symbols, just as we did in the other one really. So it says simplify by collecting like terms, always take the sign before the term. Let's have a look at some of these. Let's just start with question A. I'm only going to do a few and I'm going to let you try some of the other questions. Okay, in the first one, we've got 5h plus 3 plus 4h plus 7. Now the only way I can simplify this is to collect like terms. So I've got 5h and 4h, and there's a plus before the 4. So it's going to be 9h. Then I've got plus 3 and plus 7, which makes plus 10, and that's my answer. Okay, let's have a look at question E. This time I've got 3a squared b plus 7ab squared. Okay, do I have like terms? Well, I've got a squared b here and ab squared here. Now they're actually not like terms, so I can't do anything with it. That's my answer. Just leave it there. Let's try question C. X squared plus 3x plus 2x squared plus 3x. Like terms, let's have a look. X squared, x squared, x, x. So x squared plus 2x squared is 3x squared, because remember, if there's nothing outside the letter or the pronumeral part, there's a 1, plus 3x, which is 6x. I would like you to have a go at the last column for homework, and if you want to do more, but that is the minimum I'll be checking. That's how we add and subtract algebraic terms, by collecting like terms. You've got to be really careful with the signs. Tell me what you learned this lesson. Any questions, as well as a hot question? Maybe you can make up a really hard, high order thinking question that gets us to really think about what we would need to simplify. And then bring your work with you to class. We've looked at how to simplify a bit more complex algebraic expressions. See you soon.